A very good morning, dear students, and a warm welcome to all of you to science. Today, we are going to learn a new lesson. Children, you might be eating different types of foods at home, right? Fruits, vegetables, right? Even fish, meat, whatever it is. So, you are eating different types of food substances. Do you know what these substances consist of? Try to learn about this in a new lesson called as Introduction to Acids and Base. Okay, let's see what are acids and what are bases. Now, you might have eaten a sweet fruit like mango or maybe banana or jackfruit, correct? Then you might have eaten something bitter like that of karela or bitter gourd, correct? And astringent taste also you might have tasted like that of the pomegranate, right? So all these have different taste. Then you might have had sour fruits like lemon, amla, or maybe tamarind, or even vinegar. All these taste what is their taste? Sour. Okay, now students, lemon or tamarind, vinegar or amla like substances acquires this taste due to presence of typical compounds in them. Okay, there is a typical compound in them which gives them this taste called as sour taste, amber taste. Sour means amber taste. Why are they getting this taste? And it's because they have a typical compound. What is the typical compound called as? Let's learn about it. The compound, such compounds which are imparting sour taste to the food substances are called as acids. Okay, remember dear student, acids have sour taste, but never go to taste a concentrated acids which are available in the laboratory. These are natural acids which are available in the foods which we require it for our growth and development. Fine. So sour taste is because of the compound called as acid present in them. Fine. Let's proceed further. Now acids are soluble in water, and even they are corrosive in nature. That means if you try to dissolve an acid in water, they can dissolve. That is why a concentrated, you are going to learn something about concentrated and dilute. Concentrated means full a full liquid is highly concentrated with the same compound, that is of that acid only. Like for example, there are various acids: hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, carbonic acid, and so on. There are different types of acids are there. So all these acids have the ability to get dissolved in water. So you can see that they can be dissolved in water, and once it dissolves in water, it does not remain concentrated. It becomes something called as a dilute acid. So you might have heard about the word called as miss all the time, many times your teachers might have said this dilute acids. Dilute acids are nothing but acids which are dissolved in water called as dilute acids. But these acids, when they are concentrated, they are very corrosive in nature. Corrosive in nature, that means they can corrode many of the things. Okay, many of the things they can corrode. Therefore corrode means spoil the things. Therefore they are called as corrosive in nature. And therefore you might have seen sometimes, if it is an acid, if you have acid in your house and all, it will be always shown this symbol, that is danger, corrosive acid. Corrosive means it can have corrosive effect on the skin also. It can corrode your skin also. Some other metals also it can corrode. So that is why you have to be very careful when it is written, this type of symbol is shown on an acid. Then animals and plants also possess acids in them. Okay, not only the fruits, but even fruits and vegetables, but even animals also consist of different types of acids. Okay, so that means acids are present everywhere. Since animals and plants also consist acid, that means acids are present almost all living organisms. Then acids present in the foodstuffs are called as natural acids or carbonic acids. Now, if the acids are present in the foodstuffs. So you can see over here different types of foodstuffs. Okay, that is all the different fruits as well as vegetables over here are shown. They all consist of different types of acids, and since they are present naturally within these plants or animals, maybe they are called as natural acids or also called as carbonic acid. But these acids are not strong as that of laboratory acids which are kept in the laboratory. No, they are very concentrated. Okay, they are strong acid. These acids which are present in the foodstuffs are weak in nature. Okay, weak in nature, and therefore you can have them very nicely. Otherwise you might think that miss is saying that there is an acid present in that foodstuff, that means we are not supposed to eat since they are corrosive in nature. No, my dear students, though they are corrosive in nature, some of the acids we require them for our immunity. Okay, mostly those substances which consist of acids, they increase our immunity system, because it helps in killing of most of the microorganisms. Okay, so therefore these acids are very important. So that doesn't mean that they will be corrosive in nature. Which acids are corrosive in nature? Strong acids are corrosive in nature. The acids which are present in the foodstuffs are not corrosive in nature, because these acids are weak in nature, and therefore natural acids or carbonic acids also can be called as weak acids. Okay, they are also called as weak acid. They are not as strong as that of the strong acid, but there are some acids which are strong in nature and they are caustic or inflammatory. What does this mean? If it the strong acid falls in your hand, then what can happen? You can get burnt. Okay, you can get burnt. That is why you should be very careful when you're handling strong acids. And for example, the strong acids like hydrochloric acid is available in the laboratory, which is strong acid. Fine. Then sulfuric acid, okay, then nitric acid, okay, all these are strong acids. Even a drop of it falls on your skin will get burnt. So much, so corrosive is it in nature. It is inflammatory. Okay, inflammatory means it gives inflammation, a sensation of burning. That is why it is also called as inflammatory, and it will burn that particular part wherever it has fallen. Okay, therefore strong acids are different from weak acids. Weak acids are found in, remember this student, weak acids are found in the food stuff which we can eat, whereas strong acid you should never go to taste or even put a drop of it on your hand, because they are very highly inflammatory, in the sense it gives a burning sensation. It can burn that particular part of your skin wherever it falls, so you have to be very careful. Okay, so these acids are also called as mineral acids. They are also called as mineral acids, whereas weak acids are called as what? Natural acids or carbonic acid. Okay, weak acids are also called as natural acids or carbonic acid, and strong acids are also called as mineral acids. And then as I have mentioned to you, they are highly inflammatory. So you can see how the burns are there. The skin gets burnt when the concentration solution falls on the skin. Okay, so you can see the picture of it. You might have heard about the acid attacks and all. Those people, once if suppose they have that acid attack, you will not see the charm which was there before. Okay, the full skin will get burnt, even the eyes will get burnt, everything will get burnt, and even the person may die also. It's so much is the injury which is caused due to acid attack. Okay, so you have to be very careful, dear students, whenever you are handling this acids, strong acids especially. So you can see how burnt is the skin of this lady. Okay, so similar, not only if it falls on your hand only it will cause inflammation or burning sensation, but even it can even the vapors means when you open the bottles of the strong acid, you will find that the vapors are coming out of it, and these vapors, even if these vapors are inhaled, these vapors can be very harmful to health. Okay, so not only that it falls on the skin, but even if it is inhaled also can be inflammatory. Then Strong concentrated acids are converted into their dilute acids, as I have told you, since they have the property to dissolve in water. Okay, they can be converted into dilute solutions, adding them into water. By adding the strong acids to the water, we can make that acid dilute. Okay, so such dilute acids are less harmful than their corresponding strong acids. So dilute acids are not that much strong as compared to that of the concentrated acid. So most of the time in laboratory, when we are doing experiments, most of the times we are using dilute acids by uh, dissolving them in the water. Fine. Then you can see, not we have just now talked about the acids. Now let's see, there are certain substances which are bitter. As I mentioned to you, different types of taste are mentioned to you in the when I started with the lesson. I told you that there are certain substances which are sour in taste, which is some substances are bitter or astringent in taste. Okay, here are some of the examples, or here are some of the substances which are either bitter or astringent in taste. Acids are sour in taste, but these substances are bitter. Bitter means what? Kadu. Okay, and astringent taste is like that of the pomegranate. If you have tasted pomegranate, you will realize how is the taste of astringent. So here are some substances which shows that bitterness, or maybe what to say, astringent taste. And even if you touch them, they are slippery to touch. Slippery means burburit, like how soap is burburit. Na? Soap is also nothing but a base. Okay, right now we are talking about what? Base. We have I have just introduced to you an acid. Now I'm introducing to you now what? Base. And how is it different from that of the acid? Acid is sour in taste, bases are bitter or astringent in taste. That you have to remember. Fine. So here one example is sodium hydroxide, which you will be learning in detail in the next year also. Sodium hydroxide is very strong base. Then there are other bases also, strong bases like sodium bicarbonate, also called as baking powder. You must have used, or your mother must have used baking powder while making either bhajis. Okay, pakoda, it is also called pakoda, or maybe cakes and all. Okay, this is used. That is sodium bicarbonate, or baking soda, or baking powder. Then even caustic soda, also commonly called as slake lime. When you dissolve it in water, it is called as lime water. So you might have heard about lime water turns milky. You might have heard this statement, right? So it is nothing but the lime water means what? Calcium hydroxide. Calcium hydroxide is its chemical name. When it is dissolved in water, it forms lime water. Okay, when it is not dissolved in water, it's called as slake lime. All these examples which I have shown now are nothing but bases. They are nothing but substances having astringent or bitter taste. So all these substances either have astringent taste or bitter taste, and they are slippery to touch, are called as bases. All these are called as bases. Sodium hydroxide, sodium bicarbonate, calcium hydroxide, potassium hydroxide, even your soap which you are using is also basic in nature. Okay, so magnesium hydroxide, there are different types of bases also. Fine, we have learned acids like hydrochloric acid, HCl, H2SO4, HNO3, H3PO3, that is phosphoric acid, H3CO3, that is carbonic acid. So these are all acids, whereas sodium hydroxide, sodium bicarbonate, calcium hydroxide, magnesium hydroxide, okay, potassium hydroxide, all these are called as bases. Okay, and their properties, the chemical properties of bases are just the opposite of that of the acids. Whatever chemical properties are there, they are just showing different ulta properties. That is why we are studying acids separately and bases separately. Fine. Now Even like that of the acids, even bases are highly inflammatory. Okay, they are inflammatory to skin in the concentrated form. There were many pictures which I could have put, but you might have got scared by looking at those pictures. That's why I have put a simple picture here wherein this person's hand has got infected due to burned due to what, caustic soda. Caustic soda is nothing but sodium hydroxide. I will not use caustic soda because it is a common name for sodium hydroxide. We call it as caustic soda. This is the burn of sodium hydroxide. You see how his fingers have got burnt just by handling sodium hydroxide. So not only acids, even bases are corrosive in nature and even inflammatory to skin. Okay, this is the property which is similar to both of them. Okay, fine. Inflammation it causes. Now we have seen now acids, we have seen bases. Now you drink everyday water to survive. Water is so important for us. But is water an acid or a base? No, my dear student, it is neither an acid. Does water taste sour or bitter or astringent? Is there any taste for water? No. Water is tasteless, and that means water is neither acidic in nature nor it is basic in nature. It is in between acid and base, and those substances which are neither acidic nor basic, they are also called as neutral substances. So water is neither acidic nor basic, and it is also tasteless. From this only we can come to know that water is neutral, in between it is neutral. Fine. Now this is regarding the introduction of the lesson. We have learnt now acid and a base and what are neutral substances. Neutral substances will be tasteless and they are neither acidic nor they are basic, they are in between. So water is a neutral substance. That is why we can drink water very easily every time whenever we desire, whenever we feel thirsty. The only substance which we can have is water, because it is neutral in its nature, neither acidic nor basic. Then let's turn on to the next part of the lesson. Now there are certain since the acids are strong, acids are very corrosive or they are inflammatory, we should never taste an acid, neither a base, because both of them are highly corrosive in nature and highly inflammatory. Then how we can come to know, even touching also, we cannot even touch, not forget about tasting, even we cannot touch them. Okay, even touching also, your skin can get burnt. Then how is it that we can come to know that whether a given substance is acidic in nature and given substances basic in nature? Natural acids, of course, we can taste, we can come to know that is sour taste or bitter taste, but can we taste mineral acids? No. For that we need to have certain substances which will indicate whether a given substance is an acid or a base. Okay, so these substances which are neither acidic nor basic are chemically inert in nature. Touching or tasting of an acid is very harmful, and hence typical indicators are used to recognize them. Now what are indicators? Substances will change the color in presence of acid or base are called as indicators. Okay, substances which change color in presence of acid or base are called indicators. Now what does this mean? There are some substances which are used to indicate whether a given substance is acidic or nature, and how they will indicate? They will change their original color. And therefore we come to know in a given acid, they will show in an acid one color and in a base another color. So we can come to know from the change in the color that whether the given substance is acidic or basic in nature. Let's see what are they. Okay, so you can see here, you can see the color change which is shown here in this case. Two paper strips are put. Do you know what are these paper strips called as? Yes, they are called as litmus paper. I think you might have heard this before in the previous classes, right? Litmus paper. So, litmus paper is one of the indicator. Okay, litmus paper is one of the indicator, and you can see how nicely there is color change. Blue colored, a strip is put in one thing, okay, and in another thing red color strip is put in another thing. In the first one you can see that blue has changed to red, and the second one you have seen that red has changed to blue. You will realize that when I show you an activity. Fine, you will realize this how the change in the color is taking place. When you will see that activity, you will see how the color change is taking place. So till then we learn about what are indicators. Okay, so what different types of indicators are there? One is the litmus paper, as I have told you. This litmus paper you get it from something called as lichen. Okay, there are certain things which are growing on the trees. You might have seen this on the trees sometimes, that there are structures like this growing on their outside part. So these are nothing called as lichens, and lichen is an association of something called as algae. You have heard about algae and fungi by now, because first chapter only you have learned about what is an algae and what is a fungi in the five kingdom classification. So this lichen is neither an algae nor a fungi, but it is a combination of both of them. It is also called as symbiotic relationship, which forms a structure like that. This is called as lichen. And from this lichen itself, what is made? Litmus papers are made. Okay, and because of this litmus paper, extract of lichen plant gives this color to them. Fine. So there are two different types of litmus paper. One is blue litmus paper, another is red litmus paper. And how are their color changes? Now blue color, if it is dipped in the blue color, if it is dipped in an acid, blue color, if it is dipped in an acid, blue will change to red. I'll again repeat, blue when it is dipped in the acid, it will change to red. But the same blue color, if it is kept in a base, it will not show any color change, which means that when it shows color change, it is an acid. When it doesn't show color change, then it is a base or a neutral substance. Fine. Second thing, red litmus paper. Red litmus paper, if put in a base, okay, red litmus paper, if put in a base, it will change to blue color. Whereas the same red litmus paper, if you put it in an acid or a neutral substance, it will not show any color change. Fine. So this is how the color change can indicate whether the given substance is an acid or a base. So there are several other indicators, like here is one that is called as phenolphthalein indicator. You can see the name of the indicator as phenolphthalein. Okay. Next is the methyl orange. Next is methyl orange. The color of methyl orange is orange in color, whereas color of phenolphthalein is colorless. It is colorless originally, whereas methyl orange is another indicator which is orange in color, and one more is there, that is methyl red, which is red in color. Sorry, this is by mistake I wrote orange. It is red. Methyl red, you can see the name of it, methyl red is red in color. All these are called as indicators. Fine, along with litmus paper. So there is another indicator called as universal indicator, which is made from the different types of indicator. It's a mixture of several indicators, and it is combined. Since it is combined with so many different types of indicators, also name of it is also universal indicator. It's because it can be used to test the different types of acids, and we can come to know how much acidic it is, whether it is highly acidic or it is weak acid, or whether a given substance is a neutral substance, whether it is weakly basic, or whether it is strongly basic, okay, from something called as the universal indicator. So you can see even the color change, or a beautiful color change. So very red, what to say, dark red, what you can see over here is nothing but the one which is highly acidic, whereas a purple color or dark bluish color means nothing but basic, highly basic in nature. Green means, the green one which is there in between is neutral. Neutral means neither acidic nor basic. Those substances are called as neutral. So now you will learn more about the color change in the activity. Fine. So you see now how is the activity conducted.